Welcome to Raw Machines, a journey exploring the most remarkable processes around the world. Today we travel to Neidenbach, where generations of craftsmen once used sheer human strength, steel tools, and hard-earned experience to master massive blocks of sandstone, shaping them into grinding stones of extraordinary precision. This is the story of a demanding yet refined craft, built on inherited technical knowledge before it quietly faded with the rise of industrial machinery. Let's begin. Located in the Buntsandstein sandstone belt of the southern Eifel, Neidenbach rests on deposits of red sandstone, prized for its workability and abrasive qualities, conditions that proved ideal for the emergence of grinding stone production. Around 1900, despite a population of fewer than 700 inhabitants, as many as 500 men were employed in the local quarries. Today, the legacy of this craft remains embedded in the village itself, visible in sandstone walls, door frames, and even the paved streets. Since the time of the Crusades, red sandstone was extensively quarried for the production of roadside shrines, carved architectural elements, and figurative stonework. A decisive turning point came in 1873, when the expansion of the railway network enabled large-scale transport, transforming grinding stones from local products into commodities distributed across regions. In Neidenbach, the traces of more than 40 quarries still testify to the scale of this industry at its peak. By the time these films were recorded, only a single workshop remained, continuing the traditional handcraft production of grinding stones. From the Kohlenweg leading into the quarry, the sandstone layer suitable for grinding stones lies directly beneath an overburden of roughly 2 meters. During winter, this soil is removed and dumped aside, preparing the quarry floor for the next extraction season. Quarrying begins in spring, once the stone is no longer affected by frost and reaches optimal conditions for manual working. The exposed surface is then surveyed and marked, with the center point and circumference laid out for each intended grinding stone. Natural fissures within the rock mass play a decisive role in detaching the stone from the bedrock. Before extraction, quarrymen also employ a dowsing rod, Wünschelrute, to locate fracture lines, a traditional technique grounded in geological experience. Once the exposed rock surface has been surveyed and marked, 2 quarrymen begin cutting the Schroth groove, a circular separation trench, around the intended grinding stone, defining the line along which the stone will be detached from the parent rock. The Schroth grooves are cut in a circular form to a depth of roughly 1 foot. The stone between these circles is considered waste material and was often reused as livestock troughs or smaller grinding stones for local crafts. In In some cases, vertical drill holes and black powder were used to break up large blocks. However, the primary method remained the Schroth technique, shaping a stone block to a predefined form, combined with iron wedges. At the deepest sections of the groove, the trench is cleaned and filled with water. Iron wedges are then set at hand-width intervals, tapped in lightly and driven progressively tighter to build internal stress, causing the stone to split precisely along the marked line. The detached block is finally levered out with iron bars and cleared, ready for the next stage of work. The quarrymen and grinding stone makers worked as a closely coordinated unit. The task of the quarrymen was to free the circular stone from the rock face, transforming it from a solid mass into an independent blank, ready for further shaping by the stonemakers. To achieve this, the surrounding cutting grooves had to be driven to a depth of 65 to 70 centimeters. The work was always carried out in pairs, one left-handed cutter, linkert, and one right-handed cutter, rector. Their hammer strokes were precisely synchronized so that force and chisel angle complemented one another, ensuring a clean and controlled separation. The principal tool was the Schroth hammer, weighing approximately 7 to 9 pounds, with a hardened steel head to withstand abrasion. Cutting a complete circular groove around a single grinding stone typically required about 2 days of labor, reflecting the intensity and repetitive nature of the work. This was a physically demanding occupation with significant health risks. Cold, damp conditions often led to rheumatic illnesses among older quarrymen, while fine stone dust caused silicosis. Tool wear was extreme. Each worker required between 8 and 12 hammers per day, as the hammerheads were continuously worn down by the abrasive sandstone. Given the relentless pace of work and the rapid wear of tools, On-site forging and maintenance were essential to keeping production going. At the last grinding stone quarry still in operation, all forging and tool maintenance was carried out by the owner himself, Colin. A small forge was set up directly within the quarry, equipped with a hearth, anvil, and bellows, sufficient to repair and maintain tools constantly worn down by sandstone cutting. When the cutting edges of the hammers became blunt, they were heated in the forge until the steel glowed red, then reforged on the anvil to produce a narrow, sharp edge. After shaping, the hammer heads were quenched in water until the steel surface turned blue, then allowed to cool completely. This hardening process, Herchen, determined the tool's hardness, durability, and cutting performance for the next shift. Beyond the cutting hammers, other tools such as the wolf, used for fine dressing and surface correction, were maintained in the same manner. More complex forging tasks, including steel buildup welding or tool restoration, were typically carried out during winter, when quarrying paused, serving as a quiet technical preparation for the following working season. At the thinnest section of the rock face, the circular outline of the grinding stone becomes visible. Here, the two quarrymen cut additional short grooves to fully expose the stone's circumference. As the cut deepens, work begins on detaching the stone at the base of the pit. From this point onward, the grinding stone makers take over. Their first task is to inspect the underside of the partially freed circular block.
That's what's been done far. Oh, cut. Just my hair, man. Wow. That's a big wedge.
To separate the stone from its bed, vertical wedge grooves are cut close to the base. The blows are delivered in a steady, controlled rhythm, forming an even trench around the underside. Because the base often curves into the rock face, these areas must be corrected with a Schroth hammer and chisel. The wedge groove is cut to a depth of about 6 centimeters. In tight corners or narrow gaps, wedges are not always required. Instead, individual holes are cut without forming a continuous groove. To loosen and lift the stone, roughly 3/4 of its circumference is fitted with iron wedges, typically between 42 and 48, depending on size, while the rear side against the rock face is left untouched. Once the center of the wedge arc is identified and marked, the wedges are driven in gradually. The most experienced worker climbs onto the stone to direct the process, ensuring even separation without tilting. A deep, muffled sound signals that the stone has broken free. At this point, iron crowbars, about 2.35 meters long and weighing nearly 70 pounds, are used as levers to pry and rotate the block out of its bed. After lifting and turning the stone, the used shroth wedges are inserted underneath for support and controlled movement. Attachment points for the hoisting gear are then prepared for transport. Using heavy levers, the circular block is raised high enough to insert large timber supports beneath it. This shows that the wedges do not fully sever the stone. Small ridges remain on the underside and are removed in later stages. Alongside grinding stones, quarrying also produced large amounts of waste stone, much of which was fashioned into stone troughs still found at many houses across the Eifel today. Formerly used for pigs and livestock, these troughs were once distributed throughout the region by itinerant traders from Niederkyle. As Neidenbach shifted toward large-scale grinding stone production, such troughs were increasingly made directly from quarry offcuts.
Soll ich da helfen oder geht's gleich an der?
Ja, das ist ein bisschen kaputt.
Oh, da geht. Da, ja. Oh.
Today, many of these stone troughs have been repurposed as flower planters, material traces woven into village life, preserving the memory of a vanished craft. To determine the most suitable working face, the craftsman places a circular stone template on the block and uses a height gauge to check high and low points across the surface. The chosen face does not need to be perfectly horizontal. Instead, it is the plane that allows the most efficient dressing, minimizing material removal while still achieving the required flatness. From this reference face, the surface is gradually lowered to the lowest point and leveled. As long as the gauge indicates remaining high spots, the stone is dressed in a controlled manner until a uniform height is reached. During this checking process, the block may be shifted slightly to ensure accurate measurement. Once a cutting plane suited to the stone structure has been established, the working outline is marked along the edge. Following this line, iron bars and hammers are used to work from the rim toward the center, removing thin layers to form the rough upper face of the grinding stone. The work proceeds systematically from the outside inward, gradually eliminating excess material. On the still rough surface, small recesses are left as footholds to allow safe movements and handling. Protruding sections within the grooves are broken away, particularly in areas where high surface accuracy is required.
It's low.
When the basic form has been achieved, the surface is finished with the wolf tool, which removes the marks of coarse cutting and corrects surface irregularities. Sandstone is most workable while still damp, immediately after being detached from the bedrock. Once dry, it becomes harder and more brittle. For this reason, the main dressing operations are carried out during this early stage.
but the jacken har stått där för bra.
Nej, jag hade hört. Det var så jag var flyger så bra.
Fine, man, not much.
For large grinding stones, precision is essential. Owing to railway transport limits, the diameter could not exceed 3.04 meters. In operation, the stone rotates at a peripheral speed of 14 to 18 meters per second, where even minor inaccuracies could cause imbalance and vibration. In the final stage, the wolf is used for a last correction, removing any remaining deviations. The surface then reaches the required uniformity, ready for the subsequent finishing steps.
That's not good job, all right.
Nej, men vad är det? Vad är det för livet?
Ja, just riktigt. Det är något svårt för dig, va?
To machine the opposite face, the grinding stone must be turned safely. Quarrymen use winches in combination with temporary support structures, stone walls and stacked timber beams, to stabilize the block and absorb impact during rotation. Thick fabric padding protects contact points, while the space behind the stone is gradually cleared along a calculated fall line.
Do not help. Stop.
A stacked stone braking structure is erected in advance to absorb force should the block slip. when the lifting gear no longer holds the full load. A cable winch is secured at the opposite edge of the quarry pit to control the movement and ensure the stone turns in the intended direction. After turning, the stone body is inspected. Blocks showing large cavities are rejected as unsafe. Once debris is removed, work continues on the second face, now facing upward. The required thickness is determined from the finished face, and its outline is transferred around the circumference to define the second working surface. The remaining stone belly is then removed in a controlled manner, working from the rim toward the center. Compared to the first face, this stage is usually faster and less demanding, as the basic form has already been established. The second face is dressed using the same techniques until both sides meet the required standards of flatness, balance, and uniformity. Once dressing is complete, the grinding stone undergoes a final inspection, is classified by size and quality, and prepared for transport, with its standardized form ensuring safe handling and compatibility with transport equipment. At the entrance to the quarry, a transport ramp was built to move the grinding stones out of the extraction area. For many years, loading at St. Thomas im Kieltal was carried out using horse-drawn carts, before gradually being replaced by motorized trucks. The transport carts used for this task were fitted with thick spruce plank platforms, measuring roughly 230 centimeters, capable of carrying grinding stones weighing between 5 and 7 tons. Each cart was positioned precisely at the loading platform, so that the pulling direction aligned with the roller axis. To load a stone, smooth, turned wooden logs were placed underneath as rollers, and a winch was used to pull the stone up the ramp. As the stone began to roll, the rear rollers were moved forward in sequence. Maintaining alignment was critical, as the narrow path allowed heavy stones to sink or drift off axis. Once the stone was on the cart, it was rolled to the center of the platform to distribute the load evenly between the front and rear axles. Because of the wide overhang, balancing had to be exact. Only then were the rollers removed. The stone was then cleaned and secured with oak beams and wooden spacers to prevent slipping or breakage. Transporting the stones down into the valley was always hazardous, especially on steep curves where a stone could slide off the track. In such cases, the block had to be hauled back onto the cart using a temporary ramp. If damaged, it became scrap.
Ja, maybe.
After descending the slope, the cart continued into the Kyle Valley, where the grinding stones were loaded onto rail cars and shipped out of the quarry region to their places of use. From around 1935 onward, artificial grinding stones and mechanized grinding machines gradually replaced natural sandstone wheels. As a result, the craft of handmade grinding stone production lost its economic function, leading to the decline of specialized skills and long-established working traditions. Today, the craft survives mainly through historical records, collective memory, and the material traces it left behind. The entire process of handmade grinding stone production in Neidenbach was far more than a sequence of technical operations. It was the outcome of specific geological conditions, historical economic forces, and craft knowledge accumulated over generations. From locating fracture lines, splitting blocks with iron wedges, and precision surface dressing, to transporting multi-ton stones down into the valley, every stage required close coordination between human skill, tools, and practical experience. Grinding stonemaking in Neidenbach flourished thanks to the natural qualities of Buntsandstein sandstone, and was further accelerated by 19th century transport infrastructure, especially the railway. At its peak, the craft not only provided livelihoods for most of the local population, but also shaped the village's architecture, working customs, and social structure. Quarries, stone troughs, transport routes, and the worn surfaces of forged tools remain as material evidence of a once thriving craft-based economy. The decline of handmade grinding stone production reveals the vulnerability of traditional crafts in the face of industrialization and synthetic materials. As new technologies emerged, faster, cheaper, and standardized, an entire system of skills rooted in manual labor and experiential knowledge was pushed aside. The craft did not disappear because it lacked value, but because it no longer fit the production logic of a new industrial age. Today, traditional grinding stonemaking no longer exists in Neidenbach as a living industry. Yet it endures in collective memory, historical documentation, film records, and in the physical landscape of the Eifel countryside itself. Recording and preserving this process is not only an act of safeguarding craft heritage, but also a way to better understand the relationship between humans and materials, between manual labor and the history of European technology. It reminds us that behind every seemingly inert grinding stone lies an entire world of work, knowledge, and memory that once shaped human lives. Thank you for watching to the end of this story. If you enjoyed this film, please like, share, and subscribe to the channel so you don't miss the next remarkable journey. This is Raw Machines. Thank you, and see you next time.